Good morning, students. Hope all are doing good, staying healthy and happy at home. And you all did the eye exercise. Make sure you're doing the eye exercise daily. Stay safe and healthy at home. Don't go outside. Follow all the safety measures even if you want to go, and don't go unnecessarily. Today we are going to start the lesson that is fluids. We are going to continue the same lesson in physics. Before that, let's see some amazing facts. So in fluids, we are discussing about pressure. So related to pressure, we have an amazing fact here. The amount of pressure you use to bite on a carrot is the same amount of pressure you would need to bite off someone else's finger, which means carrot is very hard and we give more energy, we give more pressure to bite the carrot. Same way, which is similar to that of the biting a finger, how much pressure we require to bite a finger. This is for example I'm just saying. So the same pressure will be equal to that of the carrot. Now let's recap. So in the last class we started with a new lesson in physics called fluids, and we discussed thrust and pressure, pressure in fluids, and then atmospheric pressure. So we saw mercury barometer also. Yes or no? Torricelli's barometer is otherwise called as mercury's barometer. Then under atmospheric pressure, we saw what is meant by gauge pressure, what is the relationship between gauge pressure and absolute pressure also we discussed. Today we are going to continue the lesson, second part of the lesson from page 31 to 35. You can refer your book if you have. We are going to discuss about Pascal's law, density, buoyancy, Archimedes principle and laws of flotation. First is this Pascal's law. So this Pascal law was named after a scientist, Blaise Pascal. So this was named after a scientist called Blaise Pascal in 1623 to 1662. He is a French mathematician and also a physicist. So what does this law states mean? The law states that the external pressure applied on an incompressible liquid is transmitted uniformly throughout the liquid. So how you can understand this is the law which is important. So once again I read this. The law states that the external pressure applied on an incompressible liquid is transmitted uniformly throughout the liquid. So if you see this picture, so when the liquid will be incompressible, when the container is fully filled with liquid. For example, if you take water and you have a container, you have completely filled to the brim, you have filled the container. Now you have some holes around the container. Okay, you are having a holes around the container, and now we are going to push the piston. So this is the piston. You are having a piston over the container on the top of the container. So when you push the piston, what happens? The pressure rushes out of the holes in the vessel with the same pressure. Okay, the water will be rushing out of the holes in a vessel with the same pressure. Before pushing the piston, how the water will be coming out through that holes? It will just drip out. Like a drops only it will coming out. But when you give a push with the help of a piston, it will start to come out with a full force. The force applied on the piston will be exerted on the water. நம்ம பிஸ்டன் மேலே கொடுக்குற ஃபோர்ஸ் என்னவாகும்? வாட்டரில் டிரான்ஸ்மிட் ஆகி அங்கே இருக்க வாட்டர் எல்லாமே அந்த ஹோல்ஸ் வழியாக ஒரே எனர்ஜியில் வெளியில் வரும். ஒரே ஃபோர்ஸில் இட் வில் பி கம்மிங் அவுட். ஸோ த ப்ரெஷர் இஸ் டிரான்ஸ்மிட்டட் ஈக்குவலி. இஃப் யூ டேக் த்ரூ ஆல் த ஹோல்ஸ், எல்லா ஹோல்ஸ்லேயும் ஒரே ஸ்பீடில் தான் வெளியில் வரும் லிக்விட். Because according to this Pascal's law, the pressure is transmitted equally throughout the liquid in all the direction, and this is what we are applying for various missions in our daily life. So one of that applications is hydraulic press. So if you see, this Pascal's law was very much famous, and it became the basis for one of the important missions. So this hydraulic press is used to lift the heavy materials, heavy objects. So now How is this hydraulic press will be working means it consists of two cylinders. As you can see here, one is here, the other one is here. Consists of two cylinders and with a different cross sectional area, that is the length. If you see, this is a bigger one and this cross sectional area is small, okay, with the small a and capital A. And the object to be lifted is placed over the piston of large cross sectional area. So I want to lift this object, which is this brown color object, that should be placed on the large cross sectional area, and the force F1 is applied on the piston from the cross sectional area A. So how you have to do is you have to take a two cylinder, one should be the smaller one, the other one should be the bigger one, and it should be interconnected in between. The object which one you want to lift up, it should be kept on the bigger cross sectional area. So all this you would have seen in this mechanical shops where they lift the cars up to for washing and all, for doing any mechanical works, all this, no, how this heavy object car will be lifted up by this hydraulic press only. They will be having this hydraulic press. This is how it will be designed at the bottom. Okay. So for example, you imagine this is a car. You want to lift up this car and you have to place the car on the large cross sectional area. Place பண்ணிட்டு small cross sectional வழியா F1 அப்படிங்கிற force வந்து நீங்கள் அந்த pistonல you have to apply. அந்த force என்ன ஆகும், அப்படியே it will travel and it will go through the large cross sectional area and it will make the car to come up. புரியுதா? இந்த சைடு நீங்கள் ப்ரெஸ் கொடுத்தீங்கன்னா, ப்ரெஷர் கொடுத்தீங்கன்னா, அந்த ப்ரெஷர் இந்த பக்கம் டிரான்ஸ்மிட் ஆகி it will make the heavy object to lift up. Now, so obviously what happens, the pressure P will produce a small piston, but it is transmitted equally to large portion and F2 acts on a which is larger than F1. கொடுக்கிறது என்னமோ கம்மி pressure தான், but when it comes this side it is increasing. So what we can do, pressure on piston of small area is given by P is equal to F1 by A1, and then applying the pressure, Pascal's law, that is the pressure on large piston of area. For small area you are giving it as F1 by A1, for large area you are giving it as F2 by A2. Now comparing the equations, when you compare both P are equal, so we are equating 1 and 2. So F1 by A1 is equal to F2 by A2, or otherwise F2 is equal to F1. Yeah, F2 is equal to F1. What is F1 and F2? They are the force applied on both the sides. So this is F1, here is F2. Yeah, ரெண்டுமே ஈக்குவலாக இருக்குது. இந்த பக்கம் எவ்வளோ கொடுக்குறோமோ ப்ரெஷர் அதே அளவுக்கு தான் இந்த சைடு டிரான்ஸ்மிட் ஆகுதுன்னு சொல்கிறாங்க. ஸோ F1 will be equal to F2 into A2 by A1. Okay, now the ratio A2 by A1 is greater than 1. So if you see the ratio value, it is greater than 1, which means the force F2 that acts on the larger piston is greater than the force F1 acting on the smaller piston. So hydraulic systems working in this way, we call it as force multipliers. So what it is actually doing, the force which is applied this side, it is multiplying accordingly to the larger side. Smaller portion இருந்து apply பண்ற force இந்த side equal multiply ஆயிருக்கு, அதனால இது force multipliers அப்படின்னு சொல்றாங்க. Next we are moving on to density.